Hello everybody and welcome to yet another math video. In this video I will be going over the simplex method. In this video, as far as the simplex method is concerned, I will be going over the basic idea of the simplex method and the vocabulary needed to be successful with it. Then I'll display a few baby steps as to what we need to transition from linear programming to the simplex method, and then there will be a couple examples at the end. Let's get it. Simplex method basic idea. The basic idea here for the simplex method is that it takes everything you know and love about linear programming, takes away the graphing aspects, and adds matrices to the fray. Here is the first of two slides of vocabulary for the simplex method. Here we go. We have an I system, I standing for inequality. It's just a system of inequalities. We have what we call a slack variable. This is a variable added to inequalities to convert them into equations. We have something called an E system, and this is a system of inequalities that was converted into a system of equations by adding slack variables. So when we take these slack variables and add them to inequalities and get equations, it's that system of equations then that we get. A simplex tableau is an augmented matrix made from an E system. So once we get our equations, a system of equations, we will turn it into a simplex tableau, which is just a fancy specific type of augmented matrix. A basic variable is a variable with only one non-zero element in its column. So this would be a column that would look something like maybe 1, 0, 0 or 0, 0, 1, or it could be longer, 0, 1, 0, 0. Just as long as there's only one element in the column that isn't 0. Moving on. Pivot. A pivot is an entry we want to be a 1. And oddly enough, a pivot column is a column containing a pivot, and a pivot row is a row containing a pivot. So it'll start out as a number normally, like close to 100% of the time it will not be a 1, and we will want to change it into a 1. And then for the last two things here, we have an entering and exiting variable, and you'll see when you have an example of a simplex tableau in a little while that an entering variable will be along the top of the simplex tableau, and the exiting variable will be along the left side of a simplex tableau. This is where we start the baby steps and get through the process of how the simplex method works. It starts out like linear programming, where you define your variables, you write the objective function, just one objective function, and you write the inequality system. From there, you will turn the inequality system into an equation system of equations, and then from there even you'll turn it into the simplex tableau. When we, of course, first start out, we write our objective function first, and that is already going to be an equation. So the objective function will be included in the E system and the simplex tableau, but it's clearly not going to be part of the I system because it's not going to be an inequality. But when we convert from the I system to the E system, we will not include the non-negative constraints. So we will leave the non-negative constraints out of the E system and the simplex tableau, but we will include the objective function in the E system and the simplex tableau. The next thing we need to do is simplify the simplex tableau by magic. The first thing we will do is we will find the pivot by doing a little process that makes more sense seeing done in an actual example. From there, we will use row operations to simplify the pivot column so that it represents a basic variable column. Remember, that would be like a 0, 1, 0 or a 1, 0, 0 or whatever the case may be. And we will continue this process. We will have to find another pivot if we can and simplify that pivot column, and then by using row operations. And then we just keep repeating A and B and A and B and A and B until all the elements in the bottom row are positive. And then at the very end, once we have a bottom row with all positive elements along it, we can interpret our answer. Continuing with the baby steps, we're actually going to do something mathematical here, and we just simply want to turn the I system into a simplex tableau. So here's everything we need in order for that to happen. So in order to turn the I system into a simplex tableau, we first have to turn each inequality given to us, except for the non-negative inequalities. We have to turn each inequality into an equation. And in order to do that, we have to add a slack variable. So this first inequality will look like 2x sub 1 plus x sub 2 plus a slack variable 1 will be equal to 9. And we do that for the other two inequalities as well. So this is what the other two inequalities will look like as equations. Now, why do we add the slack variable? It turns out that if 2x sub 1 plus x sub 2 is less than or equal to 9, what we can do is we can add this variable. Again, it's variable. We don't know what number it is, but we can add a variable to this expression here that will make it always equal 9, because it's either got to be less than or equal to 9. And we want to make sure it's always equal to, that way we can put it into a matrix. Now, as I mentioned, we also have to include the objective function in our E system. So in order to do that, you'll notice that all of these equations here have got all of the variables on the left side, all of the constants on the right side of the equation, and we need to make that happen for this equation as well. So before we even try to throw this over here, we need to make sure that all of the variables are on the left. So I'm going to subtract 15x sub 1. I will subtract 20x sub 2, and p is already on the left side, equals 0. And the objective function will always be the bottom row of our matrix, or the last equation in our E system. So this would represent the E system that we would have, the system of equations that we would use for our simplex tableau. Again, including this, I did not write it down here. Now, the simplex tableau, if you recall from turning a system of equations into matrices, an augmented matrix, each column represents a different variable. So each equation you can see here is x sub 1, x sub 2, x sub 1, x sub 2, fine. But the first equation here has s sub 1, so we have to include an s sub 1 column. We have to include an s sub 2 column. We have to include an s sub 3 column, and way up here we have to include a p column. Ooh boy, that's a lot. And we know that there will be 4 rows because there are 4 equations. Now, the bottom row, I was saying, will always be the objective function. The last equation will be the objective function. So in addition to having a larger than normal matrix that you're used to seeing, you'll also see an extra line in these simplex tableaus that goes horizontal, left to right. But now we can go through and fill in all of these coefficients here. So I know for x sub 1, I will have 2, 1, 1, and then the objective function underneath this line, the x sub 1, is negative 15. The x sub 2 would look something like this, 1, 1, 2, and the objective function value coefficient for x sub 2 is negative 20. Now s sub 1, there's only one s sub 1 in this equation, and none of the other equations have an s sub 1, so this column will look like this. And then the rest of these s sub 2, s sub 3, p columns will end up looking the same. Sorry, they'll end up looking similar. So the rest of the matrix would look something like this. So as you go across each row, you can see it represents a different equation that we had in our E system here. So the first one had two x1s, yep, one x sub 2, yep, one x sub 1, yep, no s sub 2s, no s sub 3s, no p's, yep, equals 9. There it is. The objective function, again, is going to be the last one, so there's negative 15 x sub 1s, yep, negative 20 x sub 2s, yep, no s's, no slack variables here, but there is a p, there it is, and it equals 0. And these other two rows follow exactly the same way. Now to bring back some more vocabulary here, there are basic and non-basic variables. Basic variables, again, are variables that you can find along the top whose columns have only one non-zero element. So in this column, all of the elements are 0 except for one, this one here. Same thing here, all of the elements are 0 except for one of them, it's this one. And so s sub 1, s sub 2, s sub 3, and p are all basic variables. So x sub 2 and x sub 1 are non-basic variables. So how would we put these variables along the left side of the matrix? As I said, there would be entering and exiting variables. Right now, you just have to use the same variables that are basic. So the first basic variable I see is s sub 1, s sub 2, s sub 3, and profit, p, the objective function variable p. And that's because, again, when you start out with a simplex tableau, the exiting variables over here will match the basic variables that you have here, s sub 1, s sub 2, s sub 3, and p. All that being said, this matrix down here is the simplex tableau, and I was finished with this example a long time ago, but I wanted to bring back the vocabulary so you could see exactly what you were working with. For this baby steps slide, you will be asked to find the first pivot for the given simplex tableau. So this is what we start doing in, once you find a simplex tableau, we have to find a pivot and start simplifying this matrix in a very specific way that changes depending upon what values you're given in your simplex tableau. That being said, let's find it. So the first thing you want to do when you're finding your pivot is you have to find the pivot column. So find pivot column. And that's super simple. To find the pivot column, you look in the bottom row and you pick the most negative number. And for this particular example, it is negative 8. Pretty simple. That's the most negative number in the bottom row, which means that this is the pivot column. This first column is the pivot column. The second thing you need to do then is some divisions. We need to find out which one of these rows, right? It's not going to be the bottom row. We need to figure out which one of these rows will be the pivot row. And we do that by dividing the elements in the last column by the elements in the pivot column. And we want to pick the smallest result there. So what this would look like is I would take 36 and divide it by 1. That gives me 36. Okay, so there's that one. Then I would take 5 and divide it by 3. That gives me 1.66666 repeating. This one is definitely smaller. So that means this is my pivot row. And this is my pivot column. And where those two things intersect is where the pivot is. So this right here, this 3, that is the first pivot. So how would you progress through this? The pivot is super important. Remember, I defined a few slides ago that a pivot is a number that we desperately want to be a 1. We want this number, this 3, we want this to be a 1. So what we could do is we could divide that entire row by 3. So why don't I do that and show you what this step would look like. So here's this first step. I'm going a little bit past what we needed. The only thing that we were asked to do was find a pivot. It's 3. But in order to continue through the process of simplifying this simplex tableau, it would be by turning that pivot into a 1 by dividing that entire row by 3. And then we would get a 0 above and below. This, also to bring back some vocabulary, would turn the entering variable into x sub 1. Again, here is our pivot. So x sub 1 would be our entering variable, and our exiting variable would be s sub 2, because you'll see why when we get into the process here. Just to give you an idea of how ugly this can get, I've used the matrix from the previous slide where we found the pivot was here. We already divided that entire row by 3. This is a slightly different reduction process than what you learned with matrices, because you cannot row swap. Out of anything here, you are not allowed to row swap. Everything else is on the table, but row swapping is gone with a simplex tableau. So once you find your pivot and you turn it into a 1 by a simple division across the entire row, your goal is to get everything above and below that 1 a 0, which requires a row combination. So you can either multiply or divide a row, or you can do a row combination. But again, row swap is off the table. So here we go. We can multiply, let's see, I guess it would be s sub 2. I'm using these labels over here as my row labels. So I would multiply s sub 2 times negative 1, add it to s sub 1, and we would replace s sub 1. And I would also multiply s sub 2 by 8, add it to p, and replace p with that new result. But what makes this more fun, you heard me correctly, more fun, that is the correct F word for this, than normal matrices, is that there are fractions, also an F word, in this matrix that you cannot escape. So this is going to be interesting. So when you go through and just do these row operations, you'll end up with a new matrix that looks like this. So here's this new transformed matrix, and it is awful, and I hate it, and I don't like it. But this is what it is, and there's just so much to unpack here. So these row operations were done. So we could turn this column into 0, 1, 0. Okay, fine. Take a look at what happened here. We had an entering variable of x sub 1 where that pivot was. The entering variable will always be above the pivot. The exiting variable will always be to the left of the pivot. So here we are, s sub 2. And you'll notice that what happened was, way back there in the beginning of this particular example, there was a row, or rather a column under S sub 2 that was 0, 1, 0. And what you'll notice is that that entire column switched positions in the matrix. Now we can't just switch it. We had to do row operations and find a pivot and all this stuff to get it from here under S2 to here under X1. But that's why this S2 changed into X1. This X1 is now where that column used to be. So this 0, 1, 0 through row operations and pivots and all that is now under X sub 1. So S sub 2 became X sub 1. That's why this exiting variable changed into the entering variable. All right, I think those are all of the baby steps you need in order to be successful front to back on some applications. So let's jump into that. On with the applications. An investor has at most $100,000 to invest. That's a lucky person. And they're going to invest in government bonds, mutual funds, and money markets. The average yields for them are 8%, 13%, and 15% respectively. The investor's policy requires that the total amount invested in mutual funds and money markets not exceed the amount invested in government bonds. How much should be invested in each account to maximize the return? What is the maximum return? Whew, that's a lot. All right, let's try to think. If we were going to be solving this by linear programming, we would definitely want to start out with defining our variables. So in this case, I'm going to be using x sub 1, x sub 2, and x sub 3. You could use x and y and z if you want to, but just to keep things consistent with what I've been doing previously in the video, I'll be using these here. And so I'm going to define these right now. So here you go. The amount invested in bonds will be x sub 1, x sub 2 will be the investment in mutual funds, and x sub 3 will be the investment in money markets. Now, up here we have three different types of investment opportunities, we'll say, and three different average yields from these opportunities. So again, the word respectively here just means that the order with which the investment opportunities are listed, that's the same order for their interest rates down here. So they'll go like this. And this is going to be important because we need to make our objective function next. So our objective function here will be, we're trying to maximize the return here. So the objective function will be however much money you have in bonds, so x sub 1, that would be 0.08, because that's the interest rate, the yield in this case, as a decimal. And we can do the same with the mutual funds and the money market, and we can call that P. So there is the objective function. I only put the P on this side because I don't have the ability to write it over here while I'm making this video. So there's the objective function. Now we need the I system, our system of inequalities. Well, hey, guess what? You know, our non-negative constraints are always going to be there, so I'm going to at least list them, and you should too, because we want to make sure that we understand that when we get to the end of this, if we get any of our x values being negative numbers, reasonableness would tell you that's not going to work. You can't invest a negative amount of money. That's called debt. That's credit card debt. You don't want that. Anyway, so here we go. We have these constraints, and what do we know? It says the investor's policy requires that the total amount invested in mutual funds and money markets not exceed the amount invested in government bonds. So we know that x sub 2 plus x sub 3 shouldn't be bigger than, but it can be equal to, the amount of money in the government bonds. Now there is one more inequality. It's hiding way back up here at the $100,000 here. The investor wants to divvy up all of the investments, or all of the $100,000, into 3 investments, but cannot go past that amount. So it can go right up to equal to $100,000, but it cannot go greater than. So the amount of money that will be invested will either be equal to 100,000 or less than 100,000. So that's what makes this inequality here. So now what we can do is we can get all of our e-systems set up. All right. And when you set up your e-system, again, we don't care about any of these inequalities here. We don't care about that. What we do care about is the objective function and the other constraints. But remember, we have to have all of the variables on one side of the equation. Well, shoot, we don't even have equations for these yet. So let's turn these into equations and get them set up all properly. So here are the equations we would use for our e-system. So for this one, I subtracted x sub 1 from both sides. So all of the variables would be on one side, and we would have a constant on the other. It would be 0. Then I added the slack variable, and I was able to change the inequality into an equal sign. Now with this inequality, all the variables were already on the left side and the constant on the right, so I was just able to add a slack variable on the left side and set it equal to 100,000 instead of having it be less than or equal to 100,000. For the last one, and I did not mention this when I was going over the objective function and writing an e-system in a Simplex tableau in the baby steps, but you want the p to be positive. So here's the p, it's positive, and the next step would be to turn this into a Simplex tableau. So when I flip over to the next slide, this will be a Simplex tableau. Go ahead, pause the video, try to do it yourself first. Here is the Simplex tableau I mentioned from the previous slide. You can see all of the equations are set up. We have x sub 1, x sub 2, x sub 3, and the slack variable, right? This top equation, or this top row, represents the equation where the investor doesn't want more in mutual funds and money markets than the investor has in government bonds. The second one represents the government bonds, the mutual funds, and the money markets, all being less than or equal to 100,000 with the next slack variable. And then we have the objective function down here. The next order of business would be to find the pivot row and pivot column. Not in that order. We've got to find the pivot column first. The pivot column is the column with the most negative number in the bottom row. So it will be this number here, which means this will be the pivot column. The pivot row, however, will be the top row here. And the top row is the pivot row because when you divide the last number in this row, 0, by the number in the pivot column of that row, 1, you'll get 0. When you divide the last number in the second row, 100,000, by the number in the pivot column, 1, you get 100,000. So we always are going to pick the smallest number. So this will be the pivot here, this 1. And thankfully it's 1. We don't have to worry about finding a 1. We just have to turn every element beneath that to 0. So what we will do is we will multiply s sub 1 times negative 1 and add it to s sub 2 to turn this element into a 0. And we will multiply s sub 1 by 0.15 and add it to row P, so we can turn this element into a 0. Now I'm going to go ahead and do these and bring up the next Simplex tableau right here. All right, here is the simplified row under x sub 3. If I put these in here, there's x sub 1, there's x sub 2, there's x sub 3, there's s sub 1, there's s sub 2, and there's P. So back up here, the entering variable was x sub 3 and the exiting variable was s sub 1. So going way back to basic and non-basic variables, s sub 1, s sub 2, and p are all basic variables in this beginning Simplex tableau. That's why they are listed over here on the left side. This is the basic variable with a 1 in the top, in the first row. Yep. This is a basic variable with a 1 in the second row. Yep. This is a basic variable with a 1 in the last row. Yep. There it is. Zeros above and below those ones. Again, you can see that this row or this column under s sub 1 has moved to be under x sub 3. So the basic variable now with a 1 in the first row is x sub 3. That'll be important when we get over to the next slide. But okay, we have a new basic variable here that we found. What do we do next? Well, we just repeat this process. We come back, we're done simplifying, it's 1, 0, 0. We come back and we find the most negative number in the bottom row. That is negative 0.23. There it is. So this becomes the new pivot column. Now, one thing I didn't get to say in the baby steps is that you do not get to reuse pivot rows and pivot columns. So even though you come over here to the right side of this matrix and you divide 0 by negative 1 and get 0, and you divide 100,000 by 2 and you get 50,000, you cannot reuse the first row as a pivot row. So the pivot row automatically becomes the second row here. So we will have to use the second row for a pivot row, the first column in this case for a pivot column, which means 2 will be the pivot. So there it is. And we are not so lucky as we were back here to have a 1 to start with. So we will have to go through and divide all of this whole row here by 2 so we can get a 1 in this place. So I'm going to do that really quickly. There it is. I divided all of those by 2, and I left them in decimal form because we already started with decimals in our matrix here. So that being said, this is still our pivot here, this 1 now, and we have to do some row operations to make sure we have a 0 above and below that 1. We have to 0 everything else out in that column. So what we will do then is we will multiply s sub 2 by nothing because we can add it right to the row x sub 3 and replace x sub 3 because that is already set up as opposites, and that'll give us a 0 when we add these two elements together. The other row operation that we will do here will be 0.23 times s sub 2 because that, we need to multiply this by 0.23 to get the opposite of negative 0.23. Add it to P, and we will place the new results in row P. So what that will end up doing then is it will 0 out this element, and I'm going to put that Simplex tableau on the next slide. So actually see if you can do these before you get over to the next slide, and I'll give you some time to pause the video and try it yourself. I'm hoping you all got this. So this is the final Simplex tableau that we need. And I want to take a moment to just talk about the different columns and how they switched around. So originally, we had this matrix right over here, this red one. We had this simplex tableau. And what ended up happening was that the basic variables s sub 1, s sub 2, and p, which we marked over here on the left side, those columns changed. It seems as though they shifted. Now we did row operations to move those columns, but they shifted, whereas s sub 1, this first one here, was shifted to be under x sub 3. That's why there's a change from s sub 1 to x sub 3. The column that was under s sub 2 also changed positions. So s sub 2 changed position to be underneath s sub 2 to be underneath x sub 1. That is why the change here happened from s sub 2 to x sub 1. Now p stayed the same. And if we needed to, we could go through this process again and find the most negative number, but there are no more negative numbers, so we're done. And the reason I bring all of this back up here, why is this x sub 3, why is this x sub 1, what happened here, is that this last column is going to tell us the final answer. What this last column tells us is that x sub 3 here, let me see here, x sub 3 here will equal $50,000. And x sub 1 will be $50,000. And finally, p will be $11,500. So let me just write that out here. X sub 3, or sorry, let me start with x sub 1 just to make it. There we go. X sub 1 equals $50,000. X sub 3 equals $50,000. And p is $11,500. And what is happening here is it's telling us, if you go back a couple slides ago now, probably 15 minutes at this point, that x sub 1, as the variable definition, was the amount in, what was it, government bonds? Yeah, this was in, we'll say, government bonds. And then x sub 2 was the amount in mutual funds, which you can see there isn't any in mutual funds. And x3 is the amount in money markets. And this is the answer. This is how much money should be put in each account. $50,000 in government bonds and $50,000 in money markets. And it also answers the other question we had, which you've probably forgotten already, and that's fine. It's been a long example. It was, what would the maximum amount of money you could make? What is that maximum? How much could you make? And that is this number right here. $11,500 is the maximum return, is the word I was looking for. And that's it. So if you wanted to, you could write a sentence. You could say the investor should invest $50,000 in government bonds and $50,000 in money markets to get a maximum return of $11,500. But that's it. I say that's it very lightly, as this example did take up 3 slides and roughly 17 minutes of your life, but I hope it was very well broken down and understandable by all of you out there who are watching this. I'm going to end the video here. I know I promised I would do another example, but this video is already getting long as is, so I will get a second example uploaded in a separate video. I very much hope that this video was understandable, shed light on how the simplex method works, and I wish you, and I cannot stress this enough, I wish you luck.